Live from New York, it's Ask an Engineer.
Hey, I'm also mesmerized by the LED display. Some cool videos.
Yeah.
That's right. It's time for Ask an Engineer. It's me, Ladyada, with me, Mr. Ladyada. We're here at the Adafruit factory in downtown Manhattan. This is where we do all of our manufacturing and testing and kitting and shipping and coding and videoing and making those like cool synthy sound.
The first two videos, the second two videos were some of our Halloween stuff, and that's music that we made. And then we had a song from one of our projects in the past. I only have "I" for you because we had our Halloween board. Yeah. But I wanted to say special thanks to Mark, who puts this cool eyeball video, and I saw them like, I absolutely have a song that goes along with it.
Yes.
There's only so many songs that you can write about one eye. And we did that. So thanks for sharing that, Mark. This made the rounds all over the internet and the socials.
I love that Phil B's eye code is just every year. It gets rediscovered every Halloween.
Breaking news, we have an eyeball.
We have so many eyeballs.
Yeah.
But it's for the next hour. The only eye I've got is for like INPI and other segments that we've got kicking for the next 50-ish minutes. We're here checking in on what's going on in the maker community, hack community, new products, videos, it's not out yet, and more. Mr. Ladyada, let's kick it because we got a lot to cover.
On tonight's show, the code is Proto for Pico. You'll figure out why as we get to new products. But 10% off in the Adafruit store all the way up to 11:59 p.m. Eastern Time tonight. Use it or lose it. These are one of the last sales of the years before we have our holiday sales and more. We'll probably run out of stuff. Now's a good time to buy a bunch of things, save 10% off on more. Adafruit Live. This is our live shows where we talk about things, including this one, Show and Tell. Talk about some of the folks that were on the Show and Tell and more. We're going to do some time traveling around the world of makers, hackers, artists, engineers, see what's happening in this world together with folks who share things. Chip shortage this week is TDK. It'll be fun. Some retro tech. This one's interesting. It's a new thing, but it works with an old thing. Find out about that. From the mailbag, we read your letters and more. Help wanted some jobs from the Adafruit Jobs Board. To some made in New York City factory footage and more from Adafruit. Some 3D printing, some INPI. We show some new products that are actually available.
Yay.
And you can check these out this week. It's Amphenol. Going to do some new products. We got some top secret. We're going to answer your questions. We do that over on Discord, adafruit.it/Discord. We can join all 35,000 of us. All that and more tonight on Ask an Engineer.
Yay.
Okay, so the code is Proto for Pico. They get free stuff when they put the stuff in their cart. What do they get?
I'm glad you asked about the free stuff because we do have freebies. When you order from Adafruit, $99 or more, you get a free Perma Proto half-sized breadboard. People love these to take their projects and make them permanent from a solderless breadboard. At $149 or more, we still have the pink PCB KB2040. It's an RP2040 microcontroller board with castellated pads. It's got RP2040 with 8 megabytes of flash. Stomach UT, USB-C. It's great for taking pro micro projects and making them even more powerful with a mega chip. $199 or more, you get free UPS ground shipping in the continental United States. And $299 or more, we have our favorite round circuit board, Circuit Playground Bluefruit It's a great way to learn coding and electronics with Bluetooth Low Energy wireless built in, buttons and LEDs and alligator clips. And we've got tons of projects in the learning system in both Arduino and CircuitPython for this board.
And don't forget, if you're going to buy things like Raspberry Pis on our site, make sure you make an account, verify your account, and then set up two-factor authentication. That helps us keep the scammers and the folks who buy Raspberry Pis and try to sell them for hundreds of dollars on eBay at bay. Also good security. Okay, Adafruit Live. We do a bunch of live shows every single week, including this one. Do it every week, 8 p.m.
Yes.
Ask an Engineer.
We're here.
We just
this
finished
is live
up,
right
we
now.
just finished up show and tell. I have.
See, I can poke him.
Yeah, we have lots of favorite projects. Every project's our favorite on the show and tell.
Yes.
However, I try to pick one that I think folks should just look at quickly because you'll get inspired, or you'll say like, wow, I had no idea. So this week, Aaron stopped by and showed a mermaid costume outfit that lights up underwater, and 30 light up jellyfish that are all synchronized. We also have a guide, and we have a guide coming out with how you can do LEDs for harsh environments, kind of like underwater on a mermaid tail.
Erin is back, and she's fishier than ever.
So if you're interested in like what's the state of the art for a lot of the things that we do, Erin is definitely pushing the boundaries of what you can do with NeoPixels and more, just about everywhere, in the air, the land, the sea, the sky, underground, under pressure.
In space.
Yeah, so check that out.
Volcanoes.
On Sundays, we do From the Desk of Ladyada. It's in two parts. The first part, we showed off a bunch of cowbells.
Yes. I wanted to show,
Adafruit.io.
the proto cowbell, which we're showing off. I did a longer demo where I showed it connected to Adafruit.io with the sensor and using the reset button. So it was a kind of a nice full test of the functionality of the Pi cowbell. And then I also showed an IR emitter board that will be coming to the shop soon, a prototype that we made.
Then for the great search, that's when we go to digikey.com and we try to find we find things that people say, hey, I need help finding stuff.
Yes.
So what did you do this week?
Well, for this week, so I showed off this infrared transmitter, and I wanted to find the brightest right angle SMT LED that was like a reasonable price. So I showed how to use the DigiKey search to find out the brightness of the LED by using like the lumen flux. The specifications that you want to look for with IR LEDs, like the nanometer wavelength, the beam spread, and also right angle versus flat versus reverse mount LEDs. But we found a really good option, and it turned out to be the one in the prototype, and it's very bright.
All right, and then on Tuesdays we do GP's product pick of the week. Here is this week's highlight.
It is the NRF52840 sensor board. This is also known as the LED glasses board because it was originally released to drive our LED glasses. This is an incredibly cool dev board for all kinds of wearable projects and remote projects. It has Bluetooth, BLE capability. You can use that for things like Bluetooth MIDI, Bluetooth HID. It has an accelerometer on it, so you can do tilt kind of stuff. I've got my little phone there that's listening over Bluetooth to what I'm doing with this neat little package. I've got a little LiPo battery under there. I am using the accelerometer, and that's actually turning one of the knobs. Listen to it as I move the fader. Little add-ons we want using I2C, and you can chain them, so you can have a bunch of stuff. I thought this was really cool to consider this board as just a dev board and not worry about the glasses part of it. NRF52840 sensor board, aka LED glasses board.
And tomorrow's JP's workshop, tune into that and more. And then Friday's Deep Dive with Tim, where you can learn about all the innards of CircuitPython and more. Time travel. We're working on a time travel song. It'll be done soon. Let's first just give you an update. With AdaBox, there is no update. However, we will have an update towards the end of the month. If we can get 5,000-ish of something, then there's a chance we can ship an AdaBox. But getting 5,000 of something at a time is not really easy. We have heard from chip manufacturers, and they said, yeah, we're really disheartened that there's no chips. So we're like,
disheartened too.
I'm like, imagine how we feel. So the engineers at a lot of these companies, they shall remain nameless. They're like, oh, we really, we're shaking the tree internally. We're trying to get some out to Adafruit, but
chips don't grow on trees, though.
they don't. So we'll see. What's most likely going to happen is we'll probably say, hey, we're going to be back in 2023 because we'll definitely be able to do an ADA box, and I think more things will catch up early next year. It's probably what we're going to do, but don't worry, we don't charge until we ship. We'll probably do an email. We don't like to send emails out to people unless there's something they could do. You can always cancel, but we have a few thousand people waiting, so just keep that in mind. If you do cancel, you might not be able to get back on when we are shipping, and we do foresee a bunch of shipping coming up soon. Okay, on our website, it's Electronic Halloween time, so do check out all of the posts, all of the things that we have. We have gift guides, all the stuff that we do every single year. Pretty much every day of the year is Halloween here at Adafruit, but we can kind of just be ourselves for the month of October. And then Philby is working on this. This is the really neat LED drippy blood
Yeah, this is cool.
technique. Isn't that neat? So I just wanted to show some Halloween-y stuff.
And he's been blogging about the updates, so check out the Adafruit blog to get
It's really neat.
the process. It's like there's a lot of details and effort that Phil B knows a lot about with costuming and LEDs. So especially if you are going to embed electronics into your Halloween costume or Burning Man costume or what have you, Aaron and Phil B they're like the experts. There ain't no better.
And then today, Ladyada was a speaker at Espressive DevCon, and if you just search for Espressive DevCon on YouTube, you can see the entire day. There were some great segments, great topics, lots of folks we knew from the community. Ladyada was in the chat answering questions. This is just a speed up. It was a half an hour. It wasn't this fast.
Yes, it was just fast. I had a lot of coffee.
Yeah, and we were showing some hardware, talking about Python on hardware and ESP devices, and then some folks said some really nice comments about how easy it is to use CircuitPython. CircuitPython is really joyful. Very joyful is a good way to describe it, and just getting up, able to do the things you want to do fast right away. And if you make it for one processor, it works on all the others too. Okay, we have an Adafruit I/O update this week. Big news. Folks always say, oh, Adafruit I/O is great, it's free, but how can I pay you if I want to do other stuff? Well, we have other things you can do if you're a Plus person.
Yes.
So for Adafruit I/O Plus, you can do things like send SMSs. You can schedule them. So imagine if you want to do a project where you're like, if the temperature gets to a certain point, I want to get an SMS, and those cost money. So we're not charging for those, but if you have a Adafruit I/O Plus account, you get, I think, like 25 or something like that. 25 a day.
Yeah.
So, and it's UTC time.
Per UTC day, yeah.
Yeah, so do check that out. It's really neat. We think a lot of people are going to use it. It's something that, I just want to get a SMS or text message when my basement starts to flood, or when I leave my garage door open. This is that easy, and it's in the low code, no code, easy to code category. And speaking of, congratulations, we have 1,000 devices on Whippersnapper. Whippersnappers are no code way to get your IoT devices doing all sorts of stuff. This is our first milestone, and we expect there's going to be thousands of more. So do check it out on Adafruit I/O. It's free to use. It's in beta. And then we also have a gift guide already for if you want to do stuff with Adafruit I/O and Whippersnapper. Here's all the devices.
Well, because we have, there's some sensors that we have supported and some we don't. So, and there's going to be another sensor supported starting next week, which people I think are going to really like. It's definitely, this is the only no-code IoT system that I know supports this very popular temperature sensor.
Oh boy! All right,
you're gonna love it.
It's chip shortage time. All right, this week it is from TDK. TDK.
It's actually not from TDK.
It's actually not coming from TDK, which stands for too darn out of stock, but that doesn't.
Yeah. Okay.
So it's an InvenSense. They bought them.
Right? Yeah, it's a sub brand. This is the MPU 6050. Now you might be saying, dude, the MPU 6050 is not recommended for new designs. NRND, but here's the deal: it's still used in a ton of stuff. People really, really love this 6DoF sensor. And look, the replacement's also not available. So don't give me that NRND thing.
What do we use it for?
We use it for a breakout, but a lot of people use it for their robots and their drones. It's like the most popular 6DoF IMU. It used to be very inexpensive, and now brokers are trying to sell it for like 10 times the cost. But we do love the MPU 6050, and we would love to have this back in stock, TDK. So maybe you can send us a reel, or you can send DigiKey a reel, and they'll send it to us.
They could send some to us and some to others.
You can, but mostly to us. That would be great. We would love to have this chip. It's not, no, there's no even lead time. I wouldn't be surprised if in a year they came back and said, "Hey, we're never making it again." This has happened to a bunch of end-of-line chips. But I hope they don't.
This is another example. Like, if you just tell us what's going on,
people really like this chip.
Just say, "Hey, look, like, we're just not going to make this anymore," or just like, "Oh yeah, like, it's used for like this other thing that you're never like." We gave them all to someone else. Like, yeah, any information, because like right now it's just like, well, what do we do? What do we do? What do we do? What do we do? So that's our chip shortage for this week. We ordered 10,000 in May of 2022, and the ETA is May of 2023.
And we sold through. We got a couple reels in 2021 that we had ordered earlier that year. We got them, and we shipped them all out. So we're out again, and we're not going to get any for another year-ish, maybe.
So that's...
The May 2023 is a guess, too. I don't know for sure we're going to get it. But I'd like to get some earlier.
This week's chip shortage.
Please.
Chip shortage. It's the chip shortage. Everything. Every way. It's the chip shortage. It's the chip shortage. Everything. Every way. Letters. We get letters. We get tweets and we get emails. Your comments via RSS. They are the best. Now it's the time for mailbag.
All right, this week's mailbag. It was sent in from Doug. Thank you, Doug. It's got my mag tag up and running, and it's the coolest little device ever. It's going to make a great little weather station console for the bedroom. I have related project where I'm using a Metro ESP32S2 as an MQTT subscriber to display real-time data on LED backpacks. Data is from a Davis weather station. I'm old. When the cool kids like me got Radio Shack size for kids' birthday gifts, but Adafruit stuff makes me feel like a kid again. I promise if I ever win the Powerball, I'll make a sizable donation to your R&D. Also, please make a giant mag tag so I can make a custom weather display that I can read from across the room.
I want to make one.
Thanks, Doug. All right.
I hope to make one soon.
Okay. This week, we have some retro tech. This one's a little different because it's not exactly old, but it works with things that are old. So here it is. A long time ago, back in the 70s, this was I guess one of the first versions of crowdsourcing ideas from Sony. It's a little truck that you put on a record, and it spins around the record stays still, truck drives around, and it plays what's on the record. And this is the statement on the website from the folks who make a modern one now. And it says, instead of a stationary needle, the needle moves around the surface of a stationary record. Record player with built-in speakers. It was developed for promotional use only, and it was first displayed as part of a exhibited internal Sony idea contest established to encourage all employees to adapt unconventional thinking. Came complete with both a motor enabling the card to run around the surface and of the record, and a cartridge and its undercarriage to ensure the needle remain within the groove. So there's a company in Japan that makes the record runner, and you can get this, and it's officially licensed. This is really officially licensed from VW. They did all the right things, and it looks like a car. Looks like a the little van, but then the secret's underneath. That's the needle, and you put the batteries in.
Yeah.
And we have our own record here at Adafruit, so we decided, well, let's make sure it works.
You tried it out?
And we tried it out. And that's retro. And of course, a warning, probably only use it on records that you don't care about.
If you have a record you
knows?
cared about, you wouldn't put it flat on a table anyways.
Yeah, or put a car on it. All right, help wanted. We have some ideas for some songs for this too. Okay, you can go to jobs@adafruit.com and you can post a job if you're a company or if you're a person who has skills, you want to pay the bills, you can do this. This is a technical customer service representative remote/email, and this job is kind of neat. It's for
Lego builder.
yeah, it's a Lego builder, and basically someone who can make stuff, who has a technical background. So there's brickstuff.com. You can check out the website, but also check out this job listing. If this is something that you consider yourself a Lego fan, you can get a job.
This is like the ultimate job for someone.
Building Legos. Yeah. All right. Moving right along. It's Python on Hardware time.
Exciting news this week.
It's exciting. So you did the, we talked
We
about
did
this
the
earlier.
expressive thing,
Did the
yeah.
expressive thing. That's now online. Check it out. There's a lot of good sessions as well. But we're up to the second beta of CircuitPython 8.
Yes.
What is in it, and why should people go try it out?
The big deal that's new in Beta 2 is we now have PicoW support with Wi-Fi in CircuitPython. SSL, sockets, TCP, UDP requests, Adafruit IO. We got our Azure library working as well. It's all pretty much working, and it acts like native Wi-Fi socket pool, and it's great for people who have a PicoW. You want to use our mass storage or USB or HID or MIDI capabilities. You want to use all of our 300 libraries that we've got. You can now very easily use CircuitPython with Wi-Fi in the PicoW. It's very fast, works great. Only warning is in order to fit SSL, we have to shrink the partition. So if you have an old PicoW, save your files, because when you program it with Beta 2, it'll reformat the disk. But you probably weren't using a PicoW with Raspberry Pi, with Raspberry Pi PicoW with CircuitPython, because we didn't have Wi-Fi until now. So, but this is the first time it's released. It seems to be working. If people are trying it out, something doesn't work, please open up an issue on GitHub. Big ups to Jepler, who slowly but surely made way through porting the MicroPython library to CircuitPython and making it work seamlessly within our socket pool system.
And this is our launch poster, and we got permission with Espressive and good timing because today was the talk that you did with CircuitPython
Yes.
on ESP32. You could check out the Python developer survey if you want things inside of Python that maybe works for devices or just regular old Python. This is kind of neat, just speaking of Wi-Fi stuff. You can pull news headlines with the PicoW and CircuitPython. Les over at Tom's Hardware used PicoW with CircuitPython and was able to display this stuff.
JSON is like amazing. It's like so much fun to do IoT projects. The huge amount of memory that the PicoW has means that you can read chunky JSON files, parse it out, get the data. It's like so fun and joyful to use.
That's what people are saying.
It's joyful.
We'll talk about some cowbells very soon. You can bong, bong, bong. And we were looking for some testers who were trying to help get the word out from River. This is an online CircuitPython IDE, so check it out. You can look in the newsletter. And, of course, there is tons of streams, tons of projects, unending. You can also, like I said,
terrain map. That was cool.
You could also check out the entire day of Espressive DevCon. It's their first event. They did a really good job with it. They use StreamYard. I'm noticing a trend with how people are starting to do developer events. They did a really good job. Today was day one. And
it only took us 2.5 years to get good at remote event streaming.
Yeah. That's the Python on Hardware news. This week, you can, of course, get this delivered to your inbox every single week. Head on over to adafruitdaily.com. That's where you subscribe there. We don't do anything with your store account. Completely separate website. That is this week's Python on Hardware. All right, we're an open source hardware company. It's open source hardware month. We have 2,750 guides on learn.adafruit.com. Lady Ada, what's on the big board?
We had a lot of
this
guides
week?
this week. Okay, first up, if you do download CircuitPython 8.0.0 beta 2 or later, and you're like, okay, I got a Pico W, and I want just give me the code, I want to get started immediately, Liz wrote an awesome guide that has like 6 pages of every setup, start out, and then like a bunch of really common examples that people want to do with the Pico W. I found it trivial to get up and running. I got my demos going in like 5 minutes. So check it out. It's excellent and should make your IoT project a breeze with the Pico W, which we've been putting in stock. So if you want one, sign up at adafruit.com. We're putting in a bunch every day now. We're trying to get through the backlog. We also have another big announcement. The user pages for the Adafruit Learning System is finally ready and available. So what are user pages? Well, the Adafruit Learning System... It's beta.
Gotta tell you it's beta.
But we have guides that we curate, we write, the guides that I'm talking about now. And one of the things that's important to us is to make sure that the guides we have for our products and projects are up to the Adafruit standard. We want to make sure they're well documented, that the photos are really good, that the code is open source, that we're using the only things we have permission to use, except when we're like being really naughty. But user pages are where somebody who has an Adafruit account, can make pages, tutorials, documentation that is not visible on the front page, but you can link to, it is publicly available. You can send people to your page. So you have wish lists, you have tutorials or hacks that you want to show
Here's
off.
one I made real fast. So this just means anyone in the world can use the same authoring system our authors use, and it is super easy. You can put products in, you can put videos in.
The media, and you can have embedded code and
let me just say the thing that, there's a lot of sites out there that are like, oh, give us your content. They put ads around it. We don't do that. This is your content. And the other thing is you have to have a sign in for others to see it. We don't do that.
Yeah.
So this is for you to have your own little space in the world.
It's your little toolkit
for
zone,
try documentation. Also, what we want to do is there's folks that maybe they're just getting started with their electronics career. Maybe they're just starting to learn how to code, but they want to do documentation. They want to write guides. Maybe they want to work for Adafruit one day. This is a really great spot. You could put your own electronics portfolio there. So this is just us trying to figure out ways that people can kind of share what we think is one of the best tools out there. So please check it out. It's beta. There's
like it released this week.
Yeah,
so,
there's a button on the pages, and you can also use the forums or support at adafruit.com if you notice anything that needs a fix in.
Yeah, but we're working on it.
What else?
And the thing is, because we had to lock it down. It's a lockdown version of what we have as the back end editor. So there's still a bit more work to do. But hey, this is pretty cool and amazing that there's now a way that people can share and make pages on Learn that use the powerful editor we've had for like almost 10 years now. But you don't have to go through the moderation process that we do for normal guides. Liz also wrote a guide on the PCA 9548 8-channel STEM QT quick I2C expander. Great if you have a bunch of a sensor that uses the same I2C address, but you don't want to you can't change the address, like they're fixed addresses, but you still need to have multiple ones connected. Liz wrote a great guide on a laser harp that used distance sensors. The laser part was a bit of a hack. It wasn't truly a laser. I mean, the laser was visually there, but it was done with distance sensors. And the way she did it was using a TCA 9548. So she was an expert at using this breakout. We also have, from Known Page, we'll show the video, the no-code IoT soil sensor with all sorts of sensors and devices attached to it, and it's like a cool 3D printed case. Liz also updated the TCA 9548 breakout. It never had CircuitPython example code, so when she did the Qt version, she went back and she added it to this one. Melissa did a bunch of work on the TensorFlow Lite guide for Raspberry Pi. You can run TensorFlow Lite on a Raspberry Pi 4 if you have 2, 4, 8 gigabytes of RAM, but with not Buster, but whatever, Bumblebee. I can't remember the name of like the current
Flapjack. The
latest version of the Raspberry Pi OS, which it's escaping me. And 64-bit
Ice cream popsicle.
ice cream popsicle has. I know they always name it after like otters. It has the latest version of TensorFlow Lite. It's a little bit slightly different to configure, and the Pi camera V2 was not quite ready for use yet either. But finally, everything started working, and so if you're using 64-bit OS, no, Buster, that was it. Or did I say, no, it's not Buster. I don't remember. I think it's whatever. Anyways, the latest Raspberry Pi as of this video. Bullseye. That's it. See, it starts with B.
Thank you. Thank you, chat.
Why would I remember this? I don't know. And like, also, why isn't it alphabetically incrementing? I don't understand some of these things. They used to be alphabetically incrementing. So
I gotta keep you guessing.
it would be like ice cream sandwich, and then it would be
Gotta
like
keep you on your toes.
J for jellyfish. I don't know. I don't understand naming of Linux distributions anymore. Anyways, check out that guide. And then Liz also did a project for using PyLeap and FogGlider on the Clue board, so you wirelessly program it, and using the onboard barometric pressure sensor to make your own barometer that tells you what the weather's going to be the next day.
Ubuntu does Alphabet, but Debian does Pixar names.
Okay, but like, wouldn't it? This is reminds
Just so
me,
you know.
This reminds me of when like the XBS2 came out, and they were like XB2, and I'm like, the XB2 is totally not the upgrade to the S1. It's a totally separate, non-upgrade version. Like most people preferred the S1.
Wow, I haven't thought about XPs in a long time.
I know, right? Like I brought that out.
Wow.
Ah.
All right. Palette cleanser, factory footage. And that is our advanced manufacturing made in New York City factory footage.
That's here.
Whether we
That's
can-
behind
yes,
us.
Yes.
That pick and place is like 10 feet away.
It's true. 3D printing. Zip, 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 zip.
Zip, 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 zip.
Okay, we have two videos. We're going to play them back to back. And Pedro stopped by the show until this evening, so you'll see the expanded versions of these projects and more. We'll see you on the other side.
You can build your own IoT garden using Adafruit IO and Whippersnapper. This can help you keep track of your plants by logging data such as temperature and humidity. Our sensor node features a batch of stemma breakouts that keep track of the air quality and humidity of the soil. All of the electronics are housed in a 3D printed enclosure that's also water resistant. This is powered by the QtPi ESP32S2 running Whippersnapper, Adafruit's no-code solution to IoT projects. Just stick this in the soil to monitor how wet or dry it is and log that data in a custom dashboard. The Adafruit Stemma soil sensor features capacitive measurements so it won't oxidize over time, so you can reliably monitor the health of your plants. With Whippersnapper, you can create a beautiful dashboard with gauges and charts so you can visually monitor the health of your garden. Setting up your Stemma sensors is really simple and easy with Whippersnapper's built-in support for I2C devices. It's free to get started, just head over to io.adafruit.com. All of the breakouts are daisy-chained together, making this a solder-free project. Links to all the parts are in the description. To build the snap fit enclosure, you'll need to 3D print the parts in your favorite filament. We made a special case for the Stemma soil sensor to keep the circuitry nice and dry. The two halves snap fit together and feature slots for ventilation. Check out the Learn Guide for a full step-by-step tutorial on building the case and setting up your dashboard. This 6600 mAh LiPo battery is placed at the bottom of the case and will provide many hours of data logging. The Cutie Pie is press-fitted into the mount and secured in place with these little built-in clips. The Stemma QT breakouts feature mounting holes so they can be secured with hardware screws. The SCD30 air quality sensor can be mounted to the bottom, making this a compact, modular circuit sandwich. To monitor power usage, we're using an additional LiPo battery monitor so we can be notified when it's time to recharge. This USB-C connector is wired up to a JST cable so we can easily power the Cutie Pie from the battery monitor. Now we can connect all the Stemma breakouts together and start logging some data. We hope this inspires you to check out Adafruit's Whippersnapper to start building your own IoT projects.
All right, and you can hang out with Noah and Pedro every single Wednesday and learn how to make all this stuff and more. All right, before we go over to Ion and PI, don't forget it is Proto for Pico. That is the discount code, and you get a variety of free things when you load up your cart. Don't forget about that too. Here we go. All right, this week's INPI, it's Amphenol.
It's from Amphenol Advanced Sensors. We featured them like 2 years ago for their infrared temperature sensors, and this week I'm sliding over slightly, and I'm going to talk about a CO2 sensor that they just released. I saw it on digikey.com/new. It is the T6793. There's two versions. There's the 2K and the 5K ppm module. It's this beautiful gold sensor. This is a NDIR CO2 sensor. Very handy and very timely. It's a good time to release NDIR CO2 sensors. Why is that? Oh, sorry, here's the details about it. You can see it next to a pencil. It's very compact, very small. I think Tel Air is the sub-brand that makes this, and it's a nicely calibrated CO2 sensor with a lot of different output modes, which is kind of neat. CO2, it's everywhere. It's in everything we breathe. We like to exhale CO2 and inhale oxygen, and plants do the opposite. We live on this planet. CO2 levels have been going up a little bit over time, which is one of the issues we have with climate change on this planet. So monitoring CO2 is something that scientists do a lot. But recently, in the last couple of years, more people care about CO2 because it's an excellent way to determine the ventilation of indoor spaces. Outside air is 400 ppm, basically. And indoor, it starts at 400 if you have the windows open, but if the windows are closed and you're breathing and there's a lot of people and you're in a classroom and there's not a lot of, outside air circulation because there's no ventilation, CO2 level will start to rise. So, we've made projects with CO2 monitors like this one Carter did, which is, got this adorable cabin and some trees in the background, showing that the indoor CO2 level is 782. As long as it's under 1,000, you're pretty good to go. We had one developer who was working on a CO2 project, and they were showing off their readings, and it was like 2,000 plus. And I was like, hey, you want to open the window. And I think DigiKey also came by. They built their project, and they're like, wow, the basement needs more ventilation. So it's good to know because it can make you a little drowsy, as well as it means that there might not be enough air circulation if you want to reduce, flu or COVID transmission, because there's just not enough air circulation to keep the air moving around. We have sensors in the store like this ENS 160, and they're a lot less expensive, effective CO2 sensors. But these, I just want to make sure people know that there's two kinds of sensors for CO2. There's like true NDIR CO2 sensors, which are kind of expensive. They're like $50 plus. And then there's the effective CO2 sensors. And this, if it says eCO2, what it means is it's actually a sensor that uses MOX, volatile organic compound sensing elements. It's a doped material that when volatile organic compounds are nearby, it changes the resistance, and you can tell if there's gases or volatile organic compounds, so like ethanols and stuff. And by measuring that, you can sort of kind of use that to estimate air quality and the effective CO2. So here you see this eCO2 reading of about 700 ppm, which is, again, if we're indoors, that's about right. The only thing is that this isn't a true CO2 sensor. It's estimating it based on overall volatile organic compounds in the air. Whereas this sensor, the T6793, is a true NDIR infrared sensor. It uses how IR light is affected by CO2 concentration. It's calibrated to give you a really good precision, accurate reading. So this one, it has really good temperature dependence and accuracy, plus or minus 45 ppm plus 3% of reading, which is really great. You can always calibrate it to be even better. There's a built-in algorithm that if this is being used for outdoor reading or readings indoor, where there will eventually have an open window so that the minimal CO2 ppm is 400, it will recalibrate because it does drift a little bit over time. The module is quite small, shown on the overhead, which I really like. And there's a lot of interfaces, which I thought was kind of like the powerful, the size and the interface is what kind of sets this module apart, as well as, of course, the accuracy. So it has a 6-pin I/O header. You can see there's a typo. I think it's the one says TX SDA. I think it's RX SCL. So there's power and ground, which you want to give it 5 volts, which is not uncommon. You need 200 milliamps for the sensor peak, about 100 average. There's control test, PWM output, UART output, and I2C output. Oh, and sorry, can you just got out of order. Okay, so the first up that I thought was interesting was PWM. So there's 2 modes of PWM. There's a 1 kilohertz, and I think there's like a 10 kilohertz version. Which I thought was really neat. So if you have a sensor that doesn't have an analog input, maybe it doesn't even have I2C, but it can read PWM pulse widths, you can use that. It'll always go low for 2 milliseconds, high for 2 milliseconds, and then you can calculate the PPM based on the PWM width. So I thought that was kind of neat. I don't have any sensors offhand. I don't have any microcontrollers offhand that don't have UART or I2C, but do have PWM. But if you're dealing with, there's some legacy systems that use old style sensors. This can be used in those places. Sorry.
10, 11, 12.
Yeah,
11,
this is,
11.
then we'll go back. So I2C, so this is, my favorite interface. So you can use, Modbus I2C registers. You write addresses, and then you can read versions, so the firmware, the PPM, reset device. So, basic stuff. The ABC logic enable, disable, that's the auto calibration based on if it's outdoor enough to, or getting low enough measurements that it'll eventually reach 400 ppm. You can measure on demand for lower current, or you can, of course, have it be in continuous mode and get measurements every 5 seconds. So, I like I2C, but that's the second option. And then the third option is UART, and they also have RS-485 transceiver support, which I thought was like really smart, because a lot of people do want to have the sensor far away. They want to use RS-485 to do, a differential signal from far away. I2C doesn't work for far away. I wouldn't use PWM for long distance, but 485, yeah, why not? As long as you give it good power. So plain UART, I think 9600 baud or RS-485. So that's all good. So again, most CO2 sensors don't have all those options. They have maybe one or two. I like that there is on this one, there's 4 or 5 different ways you can connect to it. There is some code that I found on GitHub. It's a little old. It's for earlier versions, but I think the register maps are the same, using I2C for their sensor. That said, the protocol is pretty simple. I think, you would read this code, you'd look at the data sheet, the app note with the I2C instructions, and they have example pseudocode in the app note for I2C as well. So that's the sensor. So I thought
Available on DigiKey.
It's in stock.
It's one of those things that you can actually get at the time of this printing. By printing, I mean screenshot and sending photons. There is 999 in stock.
Yes, so maybe we can show it on the overhead, because I want to show it's much smaller than I expected. I really thought that this would be larger. A lot of CO2 sensors are quite big.
That looks gigantic on the screen.
It looks, what's a really good photo. It's like, ooh, golden, but it's actually, very tiny.
It's like a miniature satellite.
Yeah, and then this is the I/O, and then this is a little my controller that does the readings and interfacing for you. But it's a very cute little sensor, and I like that, it's through a hole, and there's, you can put headers on both sides, so you can just have it plug into your system, because these only last, they're not meant to last more than, maybe 5, 10, 15 years before maybe they have to be pulled, or, they can get contaminated, especially if they're in a caustic environment. So they're easy to replace.
And that is this week's on MPI.
On MPI.
Okie dokie. Before we get off to new products, code is Proto for Pico, and you'll find out why very soon, because it is new product time.
New.
No.
Singing?
You can sing, yeah.
Oh, no, because it's, oh, no. Well, the outgoing.
The outgoing, we're
broadcast.
going to have more countdown.
Okay, sorry.
So first up,
we've got a bunch of little QSpy breakout boards. So, when I'm working on dev boards or my controller, CircuitPython, or even actually little embedded Linux boards, QSpy flash memory is often used when you want like 2 to 16 megabytes of data. These chips only come in SOIC, and I'm always like, I just want to like wire it up, and like I don't want to have to hot air, the chips on and off. Also, there's some projects that used to use the dip versions of these chips, which have been discontinued. So I thought I'd make a little breakout, just for each one of these chips. The 16, which is 16 megabit, 2 megabyte. We also have the 64, which is 64 megabit, 8 megabyte. And then finally the 128 megabit, which is 16 megabytes. So these are all, it's the same. Oh, wait, go back.
whoa,
Sorry, you back it up.
I meant to do that.
Back it up.
I meant to do that, I swear.
Okay, that's fine. All right,
Yeah,
so
so
stop
these
here.
are the three.
There's 3. There's 16,
Yeah.
16, 64, and 128 megabit.
Okay, that's
So
where my mistake
each one
was.
of these is, that's fine. It's the 24. It's the 24Q, 120, XXX, JVISSQ. Basically, it's the quad version, the QSPI version of these chips. You can use it in non-quad, so single channel or dual channel SPI. However, just because I tried this and then realized it didn't work, the quad enable bit is permanently set. So first off, you don't have to set it, yay, because most people don't want to have to set it. But you also can't disable it. So that hold and write protect pins that would normally be there for SPI mode don't function. It's really meant for quad SPI only, although you can use it in plain SPI mode. It's also only 3 volt. It's a basic little breakout, but for a couple bucks, basically, I was just tired of soldering, these to breakout boards. So for people who want to use these in CircuitPython, for embedded Linux, for MicroPython, or you can use our Arduino SPI Flash library to interface with these, and you can use them as like mass storage. They're just really inexpensive, and if you don't need a full SD card, you just need like 2 to 16 megabytes. These work really well, and they're very simple, and they're now they're aligned now with the dip size. They're 0.3 inches, 0.1 inch spacing. So if you want to use them in a breadboard or in a board that has a 8-dip socket, this will fit just fine. We give you some header as well.
Okay. Next up.
Okay. Next up, we got ahead of ourselves. So if you're using Stemma QT, and who isn't nowadays? I mean, it's like so hot. It's all the fashion. Stemma QT and Quick and all of the similar I2C pluggable devices are really popular. They're chainable. They're super fun. But there is one thing which I always have to warn people about, which is that if you have something like a Metro Mini V2 or an Arduino or any other older microcontroller system that has 5-volt power and 5-volt logic, you will want to do a I2C level shifting and power shifting to make sure that you don't blast 5 volts into your 3-volt sensor or device. Like this HT20 actually happens to be 5-volt compatible. But, you know, if you're using a BME 280 or if you're using the ENS 160 or you're using, any other sensor or device, almost all chips that are on I2C are 3-volt logic only. And if you put 5 volts into them, you could damage them. And so this logic level shifter is something, you can see the arrows, it takes 5 volts and it gives you a regulated output. It has a 500 milliamp 3-volt regulator and a 5-volt to 3-volt logic level shifter. So you can take 5 volts from your Uno or from your old ST board or your PIC Basic or whatever you've got that's 5 volts, and it gives you a clean 3-volt output. It also gives you breakout boards for pins for 5 volts and 3-volt logic and power. So if you want to use this on a breadboard, it's also kind of like an adapter. But for Adafruit boards, to be honest, all of our boards are 3-volt or 5-volt compatible. But there are a lot of other people making boards like the SparkFun Quick, which is the originator of this standard, and other companies. They may not make them 5-volt compatible. And I just want to make sure people who are still using Unos, and there's a lot of them, can safely take advantage of this plug-and-play system without, causing damage to their sensor devices.
Okay, the star of the show tonight, besides you, Ladyada, our community, our customers, our team, and all of the gold-plated diamonds out there, is more cowbell.
Yay!
I could have used a little more cowbell.
That's right. We're about to kick off so many cowbells that it is cowbell, cowbell, cowbell. That's why we
You're going to say...
What?
I gotta have more cowbell.
Actually, you won't say that because
I need
you'll
more
be...
cowbell.
You're going to be tired of cowbell.
What's the first cowbell?
Okay, so the first cowbell I made, I always start with a prototyping board because that's how I actually prototype the other cowbells. So especially for the Pico W, if you want to do IoT projects and you want to use our Stemma QT sensors, or if you want to just easily reset your board, this is a little prototyping board. It's very inexpensive. It's designed to just be like a little throwaway. You can solder headers onto it, plug in your Pico, and it gives you a prototyping area. And I'll point out all the prototyping area stuff. And then it also gives you a Stemma QT and a reset button. So it's like kind of like a handy beginner getting your project started, but you don't need a lot of complicated extras on your board. So let's go to the overhead because I gotta explain how this works. So the Pico, actually, a lot of times people either have it with headers attached or they solder on headers. So that when you get the Proto Cowbell, it does not come with headers, and the reason it doesn't come with headers is because you can configure it in so many different ways. You can plug in these skinny sockets if you want it to be super slim. You can put in these stacking headers, which I recommend, or you could put in these socket headers. And we don't want to assume which one you want. Personally, I like the stacking the most because it means you can then plug it into a breadboard like so, and then you plug in the Pico on top, and you have a little bit of space over here. What does Christopher Walken say?
I need more cowbell.
All right, well, we'll keep going. So there's plenty of space so you can solder in components, capacitors, connectors, whatever you need to. There's an edge mount reset button. So reset button is not built into the Raspberry Pi Pico, but it's very handy, especially if you want to go into bootloader mode by holding down the boot select and resetting, or if you just want to reset your board. So there's a little edge launch reset. So you don't have to unplug and replug your Pico to, load CircuitPython. And then on the other end, we've got a STEMMA QT connector. So it's got 3-volt power, ground, clock, and data. And the clock and data are connected to pins IO 4 and 5. That's because it's the default Phil Hauer Arduino Core wire I2C interface. If you're using MicroPython or CircuitPython, you'll just want to pass in 4 and 5 as the initializers for the I2C connection. So all the grounds are the square, white rectangular, because there's a lot of ground pins, and then this is the ground pad. Every pin has a duplicate, so this is IO 13, and there's this is what connects to the Pico, and then the pad next to it is you can jumper it. So every pin has like a little twin sister next to it, so you can jumper to it. And then the 3-volt line is the only one that it's extended out, and this is all 3-volt because you'll probably need a lot of 3-volt power. And the rest of the pins are kind of like a little breadboard 4-row connects, and I think there's like 13 rows of 4. You can always cut the pads if you want to have them separated, but chances are you want to make multiple connections to each row. It's not a huge prototyping area, but it's designed to be skinny and fit underneath your Pico or Pico W for quick prototyping, and it's like only a couple bucks. So, you get it. I recommend, again, the stacking headers. I think those are the kind of the most fun to play with because you can plug into a breadboard. But if you want to not have a breadboard involved, you plug this in and it fits underneath compactly. Or if you want like a super skinny, barely any space, but it's the most compact sandwich, the super skinny socket headers work as well. There's no such thing as skinny stacking headers, unfortunately. These are the 3 options that we've got. But this is, and it got a nice silk screen with Penguin. Oh, and one last thing. So the I2C also has a breakout here. These 4 pins are the I2C JST breakout. So clock, data, 3-volt, and ground. And that's for, in case you don't want to use IO 4 and 5, you can connect to the I2C power and data and connect them to other pins. You actually don't even have to use it for I2C. You could use it for just GPIO. Like, there's no pull-ups, so even though it's designed for I2C usage, you don't have to do that. So this is our first cowbell.
I got a fever. And the only prescription is more cowbell.
All right, and that's new products for the week. Okay. Don't forget the code is Proto for Pico. And we're going to do some top secrets, so go put your questions on adafruit.it/discord or discord.gg/adafruit. Let's do some top secret while folks are loading up some questions. Are you ready?
Yeah.
Here we go. All right. Somebody just said, Paul just said that DigiKey just put a bunch of Pico W's in stock, so you should go get them and then get
Yes,
one.
we'll also have to give them DigiKey, of course. They'll also, I'm sure, have this Pico Proto breakout board,
right.
but we'll also have them in.
All right, this week's top secret, all aboard, it's a STEMMA.
It is a STEMMA. This is actually a classic STEMMA, not the I2C style, but that's okay. So I'm just, these are actually quite popular. People really like these little solderless, you can use alligator clips to connect to a little board that does one task. So this is a little MOSFET driver. It's got a 4 amp power transistor N channel, a Schottky diode for flyback control, capacitor, power LED and indicator LED. And this, it's for like fans or simple unidirectional motor, solenoid control, because it's like, it's not hard. It's like, people are always like, oh, why can't I just plug the motor directly into the pins? It's like, no, you need to have a power, transistor to do it. So just making it easier to connect, fans or solenoids or motors or other, maybe powerful LEDs where you want to have a PWM input and just have all the transistor logic in the pull downs. So this is, I'll just touch this to 3 volts and then this goes off. And there's a little indicator to tell you that it got the signal. So it's a little simple board. It's going to be like very inexpensive, but very useful for people who want to have a solderless power transistor circuit.
That's top secret. Okay, we're going to go off to questions right away. We'll get chatting here. Okay, first up, not a question, just nice compliments. I'm gonna say it. Great board design as always, Adafruit. I like how all the grounds have white silk screen around them for the.
Oh yeah.
So.
No, I think Phil B helped. I think with the silk screen for that, and then the Penguin silk screen generator, of course, did a lot of the magic.
How many stemma modules do you think could be Daisy choo-choo trained back to back before the voltage drop becomes an issue?
We actually had some in the forums who had 10 stemma I2C sensors connected, chained together, and it actually isn't the voltage drop that's the issue, it's the capacitance on the I2C lines, because it started to get to like a meter or two. That's where I would get our QT hub, because that way it's a star pattern rather than a chain, and that'll help a lot if you want to connect a lot of boards together.
Okay, the feature request for maybe a future proto board, .23, QFN, etc. options.
We do have SOT23 and QFN breakout boards, not with chips already on them, but we do in the store. I made a whole bunch of them because I was very tired of spending like $30 a piece for censored boards that were the prototype boards that were available at the time. They were very nicely designed, but they were really expensive. I wanted like ones that were only like a buck or two a piece.
Okay, in the chat, the record for one of the community members, I2C sensors is 24 linked together.
You can do it as long as you have strong enough I2C drive.
There should be some type of electronic online Olympics.
Oh yeah?
Where you have like number of sensors you can.
No, they have like
together.
the Wi-Fi distance shootout they have at DEF CON, right? But it's like I2C shootout.
I feel like that's one where everyone could participate too, because it's just like, it's kind of wholesome.
Yeah.
And we don't have to drug test anyone. I don't think anyone could cheat. Okay. Yeah, be curious. But 10 is a good number. Doubt I ever chain that many, but good to know. Okay. Let me see here. Also, the I2C repeater bus board. I don't think that's a question. Can you multi-stack on the proto boards?
You can multi-stack all you want, but you'll just have to keep stacking. And of course, the I2C are all connected. Yeah, you can stack this. I mean, it doesn't have any active electronics on it. It just has the reset button. That's why I didn't want to add pull-ups or anything. Didn't want to like have any active components, but I was like, and I was going to originally do the proto board without the reset button and the STEMMA QT connector, but I was like, man, I feel like those are such like the minimum now for people's projects that I just was like, okay, let's add them on.
Okay. And then someone asked if we saw the JWST Pillars of Creation photos that dropped today. New album from the Cosmos.
Did you?
Yeah. We're going to be posting them up on our site. They look pretty good because they also did a before, well, not before, but Hubble. Optic. No. And then Hubble did this good. And then the latest in infrared.
Is the Hubble still running?
Yeah.
They're still getting data from it?
Yeah.
So cool.
Yeah. In fact, I think when... I think it was a DART mission. I think Hubble looked at the asteroid that we wanted to hit, and then also JWST did as well.
Cool.
Okay. And I think that is it. Let me go check over here. Yes. Those are our questions for tonight.
Thank you.
Thank you, everybody. That's our show for this evening. Special thanks to Zay behind the scenes, who's helping out in the Adafruit Slack and answering customers and more. And thank you to everybody for joining us tonight. You have a lot of choices on how you can spend your Wednesday evenings. I hope you had a good time. We very much like your presence here and all the good thoughts and the sharing and helping one another and making cool things together. So thanks for joining us this evening. Don't forget the code is Proto for Pico. That is our show this evening.
I made sure we had cowbells in stock so you can go and get them.
Every time you say cowbell, every time you say cowbell, you got to make cowbell sounds.
Where's the walker?
What, the Christopher Walken?
Hey.
Why aren't you purchasing something? Okay.
Okay.
It's been an Adafruit production. This is your moment of Zener.